try and make this short today and as simple as I can possibly make it. So the next part of what we're going to deal with is engineering drawing itself, the actual drawing and tolerancing. So we've covered most of the modeling that you need to understand as far as I'm concerned for the year. So that's all the hardest parts of the modeling done. You don't need to worry about, other than being helped with your project, you don't need to worry about other kinds of modeling, not in a major way. So I've just created this part here, and I want to show you just the steps that you need to follow to dimension it properly, and that are going to contribute to good tolerancing dimension practices. Okay, so I'm going to go to File, Make Drawing from Part. I'll select that, see what happens. I can't remember how big this is. Okay, and as before, you've seen you can just drag a view in your view palette. So we're going to select the front view. And I want a copy of, sorry, this is the top view and that's the front view. Yeah, this might be a bit small. So I'm quickly going to hop over to my sheet. Is it sheet format? I think it is sheet format, and just select a larger sheet format if I can find it. A2, there we go. Okay. That's just to give me some space to dimension in. Right, so I'm going to hop over to this illustration I created in Rhino first, just to try and illustrate the beginning process or the thinking process behind selecting datums and then selecting the dimensions. Right, so the first datum that you ever are going to select, I'm just going to hide this for now, will typically be the starting point of whatever machine that you're beginning at. So I've just sort of not modeled these up, well, kind of modeled some of it up. This would be a bed of a milling machine. This would be the head of the milling machine. This is from a kind of sophisticated 5-axis milling machine, so I've skipped out a whole lot of it. And typically the milling machine would be able to come up and down like this, left to right, front to back, sorry, and then left to right. And then the more sophisticated ones will actually be able to rotate like this and do the same sort of thing. So go left to right in those sort of axes. So this is what you've got to try and think about, is whoever sets this machine up or operates it needs to understand where they're going to zero their dimension. So the 0 point is the point at which the cutting head meets this base plane. All right, so you show this part again. So this part is now sitting on top of that base plane, and it would be fixed to this mounting plate. Not the way I've shown you. This is quite crude. This is not how they do it. Just move that up a bit. So you've got to consider, primarily in this case, or in most cases, how whoever's going to make it, how they're going to measure how far to come up. So let's assume this part here was in fact one big block. So if you can picture that this was, let's just quickly go in here. Draw a block quickly. Right, so typically if you're going to machine this part, you would start off with a block of metal that looks something like this. something like that, and then you would machine away the bits and pieces so that you'd end up with what's left over. So that's not how you do everything, but that's certainly a lot of what you're going to be doing relies on this kind of process. So I'm illustrating this process. It depends on the process as to where you select your datums. So hopefully that makes sense. That plane there, this one here, would be the first datum, the primary datum, the A datum. Then you would go back and you'd say, well, which other two datums make sense for this machine to start with? In this case, I'm going to select that face as a B and that one as a C, because from those two planes, I can now get the machine to move in the X and the Y axis and the Z axis relative to those two planes and the bottom one. Does that make sense to everyone so far?
Yeah.
So when you dimension this thing, this is what I'm going to be looking for, that you're actually thinking about how would you tell a machine or a machinist to go about making the part. There are other aspects to tolerancing that we'll get into, like assemblies and function. Those are just as important, but for now, let's just start with that approach, because that's essentially what you have to worry about at this level. Okay, so go back to my drawing. I'm going to save this just because old computer and RAM and stuff. So if I save it, I free up some RAM. I'm just going to call it that drawing. And John, was it you who was asking about file extensions?
Sorry, sir, I didn't hear it.
I said, it was you who was asking about file extensions, solid part and solid draw.
Yes, it was me.
Okay, right. So just quickly have a look here, so that if I save this, let's just save as, just to make it clearer. You'll see here that in my file name, the extension is whatever kind of drawing it is, SLD, DOW. So I can select here whatever I want. So I can make it a PDF. You'll see the extension changes to PDF. Does that make sense?
Yeah, it does make sense, because I thought we only sending the PDF file to you.
No, so you're going to save it as a solid draw file, but you're going to send it to me as an PDF. I can't remember what I asked for, but whatever I asked for. So I think I asked for a solid draw, not a PDF to go. But whatever it was, I'm not going to hold myself to it, because I will incriminate myself. Right, so that's the starting point. So let's go quickly to datum feature, and according to what I've just shown you, that'll be the A datum, primary datum, and then this face will be the secondary datum, and that face will be the tertiary datum.
Hi, Phil. I typed it in the chat.
I see there. When you have a round object like a wheel, stool, seat, what are the datums? Yes, good question. Always there will be the centers. So I'll do that just now, but maybe I can explain it here as well. So what have we got here? We've got what you should be on the alert for is any kind of pattern in what you're doing. I mean, you'll be aware of it because you would have made the part. So whenever you've got a pattern, you want to reduce the number of dimensions that you have. So here are some of the rules. No, I'll post them later, but some of the rules for dimensioning are, one is that you want to avoid what's called redundancy. So redundancy is the duplication of a dimension unnecessarily. Now, redundancy, if any of you have ever watched one of those disaster movies or documentaries on planes, where they put redundancy in, they put like 3 systems of brakes in and 3 systems of fly-by-wire. Redundancy is a repeat of something in that kind of industry. redundancy is good because you want 3 different systems in case one fails. In this kind of drawing, redundancy is bad because you want the clearest message possible to come across. So the fewest dimensions and that capture the greatest amount of information. So patterns are an immediate giveaway that you can actually reduce the number of dimensions. So let's just deal with the patterns first. So I'm going to put in a center line. Don't know if I'll be able to get this right. No, that's not going to work. Actually, I hadn't thought about that. Let's see if I can do it like this. From that point to that point. No, it doesn't do it. Okay, so this is one of the instances, one of the few instances where you might have to actually draw in a center line from a center to a center. And then not sure if we can. Yes, we can. We can extend it. So that's because I think here center mark won't apply to this. It will. Okay, that's in fact a better way of doing it. So anything with a radius, you can in fact add just a center mark. Let's add the center mark to this as well. This should actually straight away, yes. I think there's a special center mark for slots. Let's go to the right hand side. Yes, there is. So if you have a look here, slot center marks, what you want is to select the slot ends. And I'll show you why that is shortly. So I've got too many center lines in here. I'm going to reduce that one. So I've got all the centers in place. So let's start with this lowest one. And so I'm going to start dimensioning from, since that's a datum, I must always start from datums. So the second rule of dimensioning, or maybe the third after datums and fewest dimensions possible, is position, position, position. So it's like being an estate agent. I want to know where these parts start and finish, and I want to know where these parts start and finish, and those, and etc. So the first thing is I want to know what is the y dimension. That's 14. Okay. And I also now want to know where do I start this sequence. So that's going to be my z dimension or horizontal dimension. Okay, so now I've got the position of, I can see what is clearly a line of the same sized item. Now all I need to do is I need to put in what the regular spacing is here, and that's called pitch. So I take one more dimension from here to here. And once that dimension is established, go into this dialog box and in front of the dimension, in caps, type in pitch. And that's all you need to do to capture the spacing of these dimensions, because that tells whoever's looking at this that each one of these is spaced at 18.5 from the next. Okay, so the next thing I need to do then is just to dimension what that radius is. And by the way, if it's not a full circle, then it's always a radius. So, oh, it's not doing what I like. Yes, there we go. So, like this is a cutoff. This is got a flat on one end. It's going to be a radius, whereas that as a circle will get a diameter. Okay, so that thing, those are things that I look out for a lot. Have you actually figured that that's a circle, it must have a diameter? And the reason for that is this is describing the geometry and the size. So the geometry is circular, and the size of that geometry is 7.5. And this is also describing the geometry. It's saying the radius, which is not the complete thing, is 5.5. And of course, well, 5.5 is the actual dimension. And then the next thing, so here's your question. Kyra. It's Kyra, is that right?
Yes, that's right. Hello, Phil.
Hi, pleased to see you. It's marking you present. Okay, so yeah, where were we? All right, so your question quickly, well, not quickly, but your question, Gabriel. In the same way that I would dimension this part from the center line to get the flat. That's the same that you do with a circular object. You only use the center lines as the basis for your dimension. So I need to know that that slot end comes from the center by the amount of 4 millimeters. And I only need to dimension one of these parts because those are all the same. So what you can do here, just to make this clearer, you can either type in TYP, which is typical, or you can say 1, 2, 3, 4, 5 places. So you can say 5 places. Yeah, I'm not going to worry too much about how you do that. If you just stick to TYP and it's obvious that there are 5 of them, then that's fine. Where you'd more likely use, say, places is, let's say you had 2 rows of these items, or you had 1 row here and then 2 more of them over there. So the total 7. Then you would say radius 5.5, 7 places. Then it's because here it's obvious that you dimensioning this sequence, whereas the other 2 might not be obvious. But whoever looks at it can count and say, aha, there's 7. I must just look for the other 2. Okay, right. So far we've covered that piece. So let's just cover this slot. So the slots, once again, we're going to start from the datum. Okay, so here's another rule that you need to follow. Always try and make your dimension lines as short as possible in every possible respect. So I could go from this end here to there. Well, actually, technically I couldn't, but just to illustrate, that dimension there won't do it. Let's go to this one here. That dimension there, let's say I drag it out this side. This dimension here line is crossing more pieces than it needs to. Actually, maybe not, but I think the principle will hold. So in other words, just as an example, if I were dimensioning that piece, put the dimension that side, don't put it this side where the dimension line is now crossing a whole lot of other features. So it's a matter of clarity. Make it as clear as possible. And the way to do that is to make your dimension lines as short as possible, or your leader lines as short as possible. Okay, so a little bit of a sidetrack there. So that's position. There's position number 1. And position number 2 is from my second datum. And here it should ideally go to the center of this. Don't know if I'm going to get that right. That's not going to do it. Okay, for now, let's just leave this like this. Actually, this depends very much on how the slot is going to interact with the other part. So this would be legitimate if it didn't matter too much, because now you could dimension from there to there. In fact, I think since this is a slot, yeah, what you could do is you could dimension like this slot, and then put the center line, the dimension between the 2 centers in, which I think is 12. There is a convention around this. I will just find it. I can't remember what it is. 12 by, let's say it's 7, and that would be diameter 7. No, radius 7. Go to the side here. Do we have a radius sign? I need to find. Sorry, I'm a little bit behind on how to do this. I've forgotten how to dimension slots. I'll update this when I edit this video. Thurston. Okay, whose sound have we got on? Don't know who that is. Right, sorry about that. I had to quickly put Thurston's name in. Okay, so sorry about this little bit of a whoopsie here. I'm a bit rusty here, Phil. Okay, so essentially what you're doing here is only giving the position, which is 10 and 12.5. So as much as possible on a slot, you give the center lines. I think this would be better like this. Actually, here it doesn't matter. So it can either be the radius or it could be the width, but not both, one or the other. And then ideally, I think this has got to do with holding the shift button down. There we go. Okay, there we go. All right, so that's all it was. To avoid you getting a dimension which looks like this, which is an angle dimension, all you need to do is hold the shift button down and then you'll get the dimension across the centers. Okay, so I'm going to move on to this next hole, which is position first. Okay, so I'm going to hold the shift button down. So I got that right, holding the shift button down. I should be able to hold that one. No. Clumsy today. Hold the shift button down. I think you got to do it before you start, yeah. There you go. So before you start, you hold the shift button down. Let's quickly get these done. Okay, you can see I'm not worrying too much about placing the dimensions for now because we've got magic buttons to do that for us. So let's quickly deal with this one, and then I think for today, that's all I want to deal with, unless you guys have questions. I want to just sort of not load you with too much. So here are the overall dimensions. And so now we just come to this this pattern here. So the first thing I do need is a position. So that's my X dimension and then my Y dimension from there to there. And what you should be able to see, what should be evident here, is that this is on a circle. So you might be able to put in, no, we can't. Right, so there is a way, and I'll find out how to do it. I'm putting in what's called a pitch circle diameter. For now, I'm just going to draw a circle in, and I'm going to connect that circle to from the center of all of them to the center of one of them. I'm just going to change that to a construction circle. Okay, so I've got position 1, position 2, which is down there, 90, so it's 1981. Now I just need to place the position of these circles. So dimension that line. Keep it driven, that's okay. And then in your dialog box, you say P, C, D. Why it's not? I've got my caps lock on. P, C, D, which stands for pitch circle diameter. All right, so pitch circle diameter just means that when you place these circles, or when you cut them, you need to put them on a circle for placing them. So you decide that your circle is diameter 52, and when you find the points at which they join, that's where you'll put them. So I could actually put in see if we can do it. No, it's wrong. I could put in an angle here of 60 degrees, because there are 6 of these, and 6 times 60 makes 360. But you don't need to, because these are equispaced. So you can just put in a note here. Right, equispaced just means equally spaced. So I've got the diameter. So this is containing quite a bit of information. It's got what shape it is, or the geometry of it, the diameter, the size, 7.5, and then equispaced. We can divide 360 by 6, and we'll get 60 degrees. And then the last thing I need is this one here, diameter 10.5. And then quickly, yes, quickly, because we don't have much time. Another rule which I will spell out is that you always try and put your dimensions in the view in which the geometry is most obvious. So I've put all of these dimensions in this top view. The adjunct to that, or the second part of that, is if you're going to dimension something in a view, you must put the dimension, the size dimension, together with the place or the position dimension. So here I've got the size dimension together with the position dimension. So that 81 and that 90 go together with that one, all in this view. Don't put any of these dimensions in another view. So in other words, don't put the position here and then put the size in another view. So in this view, all I want is the heights. I need the height and the angle. So it's that one. That one. That one. And I don't need to dimension anything else other than this angle, which I can actually dimension in this view. There. Okay, and in fact, now I'm going to dimension from that point to that point. So we're going to go backwards, because I want the machine to start from that point upwards. Okay, I think that's it. Then to organize all of this, I just drag, select from left to right, right click, go to align, go to auto arrange, and it'll neatly space things out. If I'm not 100% happy with it, I can just move things out of it. Oh, and my computer is just slowing down radically. But it'll place the dimensions then for you from largest to smallest. And you can just then rearrange a little bit. So make it as neat as you can and as equally spaced as you can. Like in this instance, I can grab just these dimensions, referring to the C datum, and just auto arrange those. It should do it for me. Spaced evenly. There we go. So it's spaced them evenly. So you can do the same with this lot here. It's fine, Thurston. I see what you're saying there. Okay, I think our session is almost up. Are there any questions? Setu, nice to see you. I hope you get your stuff sorted out.
No, I haven't. It's still not working. I'm
Still not
thinking
working.
about
Okay, well,
using Fusion 360.
speak to me afterwards. I'll see if I can help.
All right.
All right, so is that clear to everyone? I'm gonna be sending you some exercises to do like this, just dimensioning, not anything else. And we're going to be going over this again, and then I'll send the rules that I'm looking for. So yeah, that's just keep that in mind. Someone have a question? No. And then Gabriel will deal with the circular bit or the equally spaced thing next week.